let's take a minute to look at some kinematics graphs. So we're going to start off by looking at a displacement time graph. And I just want to review some basic math with you real quickly. Whenever we are calculating the change in y value, change in x value, the slope of the line, the type of relationship between variables because of that slope, all of those things are going to be the same that you're used to with your math class. So if we are looking at the y-axis here, we're going to evaluate how that y value has changed, the same that we would in math. We would evaluate what the value for the slope is, the same that we would in math. However, now that we are in physics, these graphs represent specific variable relationships. So rule number one is that you always read your labels so that you know what variables you are interpreting based off of the graph, because the variable that is listed on that y-axis or that x-axis is going to change how you interpret the meaning behind the change in y value or the slope that we see on the graph. Okay, so let's talk about displacement time graphs in general. Whenever we are looking at a displacement versus time graph, if I ask you to tell me the change in position or the displacement that the object experienced, in this case, we are looking at the y-axis. We can see that we have the variable displacement listed here on the y-axis. So if I wanted to know the displacement for my object from 0 to 2 seconds of time, then I'm simply looking at this segment of the graph here. And so I would say that my object had a positive 2 meters as its change in position, or the displacement was a positive 2. Now, if I'm in math class, you might hear this referred to as the rise. And the way that we calculate our rise is by determining the change in the y value, which specifically would be y2 minus y1. Okay, if I were to ask you for the change in x value, we went from 0 to 2 seconds of time. This is sometimes referred to as the run. And so we would calculate that by simply calculating the change in the x value, which would specifically be x2 minus x1. Now, in this case, the x value is time, and we're going to see that quite a bit. There is no such thing as negative time, so let's just remember that. And then make sure that you are only using the time value for the segment in question. So I sometimes see students just basically moving a little too fast usually. If I were to ask for the slope or any information about this negative slope right here, then I need to make sure that I'm using 2 seconds of time, because 6 minus 4 is 2, not the full 6 seconds. So that's something that I see students do a lot, and I think it's just because they don't slow down to be more careful with that calculation. So if we are looking at the slope on this particular graph, then I would do just like in math, I would do rise over run, okay? So in this case, my rise is a positive 2, my run is a positive 2, so I end up with 2 over 2. But then what would the units be for that slope? Well, my slope is my change in the y-axis, which in this case is measured in meters, and my run is the change in the x-axis, which in this case is seconds. So if I look at my units, I am left with meters per second. So if I were to ask you for the slope on this graph for this first segment, it would be 1 meter per second, which means that the slope represents the velocity of our object. Okay, remember, change in velocity is our acceleration, and we'll talk about that more here in a little bit. Okay, so when we're looking at a graph, whenever we have a positive slope for our position time graph, then this means that I have a positive constant velocity, because any point in time on this slope right here, I would have the same slope value, or the same rise over run, the same answer in meters per second. Okay, if I have a segment of the graph where my line is horizontal, that means there is no slope. So since this is a position time graph or a displacement time graph, my object is not moving. There is no velocity. And then if I have a segment of the graph where there is a negative slope, then remember these would be displacement values. This would be position values. So 1, 2, 3, 4, 5. So here my change in y value would be it's always final minus initial, sorry, so it's going to be 2 minus 4. So this is going to give me a negative 2 meters for my displacement. So this means that the direction of my motion is in the negative direction. My object traveled 2 meters in however many seconds of time. So a negative slope on a displacement time graph is going to give you a negative constant velocity. And this just means that my object is moving backwards, okay? These changes in the slope here, or if my graph were to do something like this, any type of change in that slope value means that the velocity is changing. And so anytime we have a changing velocity over time, remember that means we have an acceleration, okay? All right, so here I kind of have it summarized for you. No slope means no velocity. A positive slope means a positive constant velocity. Negative slope means a negative constant velocity. And so when we're interpreting questions, or if you're looking at a graph and interpreting that graph, we're going to say that our object is moving backwards. Or remember, we said in general, right and left. Right is forward, left is negative. So we might see the phrasing that it's moving to the left. And any type of changing slope, curved slope, means that the value for the velocity is changing, which means by definition the object is experiencing an acceleration. And remember, acceleration just means change in velocity over time. It does not mean that it's speeding up or slowing down specifically. It just means that it is changing, okay? So if we are looking at a velocity time graph, there's two things that we need to look at for a velocity time graph. We need to look at the slope, and we need to look at the area under that slope. So let's start off by looking at the slope, okay? Remember, rule number one is you read the labels on your graph. So we're going to interpret the change in y value and the slope on this graph a little differently than the last, because the y value is now representing my velocity. So always read your labels because it changes how we interpret the information, okay? So if we are looking at this particular graph, no slope, where on the graph do we have no slope? Well, from 5 to 12 seconds, we have no slope. So what does this mean? In this case, the y value is my velocity in meters per second. So this means that the y value does not change. So my object is moving at a constant velocity of 4 meters per second, which means it is not experiencing an acceleration. There is no acceleration, okay? Now, how can we know what part of the graph is the acceleration? Well, the y-axis is my velocity, the x-axis is my time. So it's neither of those places. The slope on this particular graph is going to give me my acceleration. And again, we're going to do rise over run, which would be my change in y value over my change in x value, which in this case is going to be my velocity measured in meters per second, divided by my time, which is measured in seconds. So either we recognize that acceleration is the change in velocity over the change in time, and so velocity over time is my acceleration rate, or we look at the units and we realize that meters per second divided by seconds is going to give me meters per second squared, and that's the unit for my acceleration. However you're going to choose to determine it, you are responsible for knowing that that slope is your acceleration. Positive slopes mean that we have a positive constant acceleration. So right here, we have a positive slope. So that means that my object is increasing its velocity while moving in the positive direction in this particular case. And we'll look at some other graphs here in just a second. The fact, though, that my object is changing its velocity, that's what makes it an acceleration. Okay, remember the word acceleration means change in velocity. The word itself does not determine whether it's an increasing or decreasing change. Okay, all right, if we have a negative slope, that means that our object is moving with a constant negative acceleration. So here, my object is changing its velocity, so it is experiencing an acceleration. My slope value is negative, which is what makes this a negative acceleration. Now it says in parentheses here, not necessarily slowing down. Not necessarily slowing down. So it depends on where we are on the graph. If I look at this last segment right here, then my object is experiencing a change in velocity. So that by definition makes it an acceleration. This is a negative slope, so that makes it a negative acceleration. But now my object has a negative value for its velocities, which means it's moving in the negative direction. So in this case, my object is going to be speeding up. So let's look at that a little bit more closely, okay? If I have a velocity time graph and I am looking at, let's label these, velocity time. All right, so if I am looking at a slope that looks like this. This is a positive velocity because my velocity values on this graph would be positive numbers. I have a positive acceleration because if I were to do my rise over run, this would be a positive change in velocity divided by a positive change in time, which would give me a positive value for my acceleration. And in this case, my object is speeding up because a positive change in velocity would be an increase in speed on this specific graph. Okay? Now, if I have a graph that looks like this, then once again, we would have a positive value for my velocity because these are positive numbers here that we are graphing. But in this case, I would have a negative acceleration because if I do my change in velocity over change in time, then I'm going to end up with some negative value for that answer because my velocity decreased in value. That is a drop. 1 minus 4 is going to give me a negative 3 for my numerator. So I have a negative acceleration. In this case, my object is indeed slowing down because it is moving in the positive direction. So a negative acceleration would mean slowing down. But let's look at these graphs down here at the bottom. If I have a graph that has a negative velocity but a positive acceleration. So the fact that I have a negative velocity means I am now on this side of the graph, okay? So a negative velocity but a positive acceleration would look like this, all right? The velocity values are negative, which means that my direction is in the negative direction. If I look at my acceleration, that's going to be my change in velocity over time. So in this case, my velocity went from a negative 4 to a negative 1, which is actually going to give me a negative value for my velocity. And my acceleration is going to be positive because this is a positive slope. All right. So in this case, my object is slowing down because we have a decrease in our velocity value. If I look at this graph over here, this graph over here, if I have a negative velocity and a negative acceleration, then my graph looks something like this. So I'm on the negative side for my velocity. I have a negative slope, which means that I have a negative acceleration. So in this case, my object is speeding up because my change in velocity is going to actually be from a negative 1 to a 4. So that's an increase in my velocity, but I just happen to be moving in the negative direction. So that's how I ended up with a negative acceleration. Now, you are going to be expected to interpret some graphs. You are going to be asked to determine whether the objects are speeding up, slowing down, whether it's a positive or negative velocity, or a positive or negative acceleration. What I want to leave you with is this. You need to make sure that you are taking time to read your labels. Take a moment to remember what that variable means. Review the definition of that variable in your mind before you begin to try to interpret the question. The direction is important. Acceleration, by definition, is a change in velocity over time. Positive velocities are going to be in the positive direction. Negative velocities are in the negative or backwards direction. And whether or not the object is accelerating is going to be determined by the direction of the object and whether it's an increase or a decrease in that object's velocity. Okay, those are the things that we are looking for. All right, the last thing that I want us to look at is the area. So when we're looking at a graph, it says the area under the slope is the object's displacement. So this right here can be used from a graph to tell me the displacement of the object. So this object went from 0 to 4 meters per second in 5 seconds time. How far did the object travel? If we're looking at a graph, we're simply calculating the area, okay? So hopefully you recall from math class, if we are looking at a rectangle right here, then we're going to say base times height. If we are looking at a triangle, it's 1/2 of the base times the height. Okay, and then because we have positive and negative values, if we are on the negative side of the graph, then whenever you go to calculate that area, you then have to recognize that this is in the negative direction. So this would be a negative displacement. So it would be negative 1/2 base times height for this particular segment of the graph, okay? So if I were to ask you for the total displacement for this graph, then you would need to calculate what the displacement is here, what the displacement is here, and what the displacement is here, and then you would add all three of them up together, but make sure that you make the displacement for this third segment here a negative number because the object is moving in the negative direction.